framework which is used to store and process huge amount of data.
Huge amount of the data and varieties of the data, right?
Yeah, by satisfying all the 5 to or 10 V's or 3 V's, whatever it's majorly used.
Yes, yes. Yeah. Hadoop. It is an open source Java based framework which will store huge amount of the data, variety of the data in a efficient manner, and also it will process the data whatever we store in it. It is a Java based framework, right? So this Java based framework actually come up with two components. One is HDFS, one is HDFS, other one is MapReduce. One is HDFS, other one is MapReduce. One second, guys. So here, this HDFS meant for store the data. It is for storage. MapReduce meant for the process the data. Okay. So how this HDFS stores large amount of the data, variety of the data, how it will in an efficient manner, how it will store. So as per our previous sessions from the demo, we have understand what is a file system, what is a distributed file system, what is a Hadoop distributed file system. So whoever didn't gone through it, I'll share the those videos. You guys can go through once again, so you'll understand in detail. So let me start with the directly HDFS architecture today. So if you see the HDFS architecture, if you see the HDFS architecture, when I say HDFS, it is Hadoop distributed file system. It is a Hadoop distributed file system. It is a Hadoop distributed file system. It is a file system. It is a file system. So it is not a database, right? So even though it is meant for the storage, it is not a database, it is a file system. So how this architecture looks? So it uses two type of machines. Two type of machines. One is master type. One is master type. That master type will call name node. That master type will call name node. This this master type we will call name node. And there is another type of machines that's called slave type. The slave type will directly call data nodes. They are data node. These data nodes are connected to name node. These data nodes are connected to name node. And we will be having one more machine. We will call it as a gateway or edge node. or client node. There will be one more node which is connected to name node, which is connected to name node, and which will actually configure the name node information in this edge node to connect with the cluster. We will call it as a edge node or gateway node or client. We'll call it as a edge. We will connect to edge node and we will try to process the data and so on. So in this master type and slave type, they will be connected together and they will be working as a single machine. We need to understand this one. They are connected together and they're working as a single machine. They will be working as a single machine. Means the multiple machines are the small multiple machines are connect together and they work as a gained machine. Gained machine means biggest machine. So how they will be connected and what their internal things happen. These data nodes, this data nodes information we will be actually configure with the name node. Your name node, like a master, will be having a complete idea about these data nodes, and these data nodes will be sending heartbeat, sending a signal to name node every 3 seconds. RPC. Every 3 seconds, it will send a kind of signal. The signal will call it with the help of the RPC protocol, saying that I am alive. I am alive. It sends a signal to the name node saying that I am alive. It means I am working and this is my block report. It also sends it's a block report. Block report means I have stored this data. With the help of this communication, name node maintains the sync with the data node. It means name node maintains the meta information about the data nodes. Very simple, guys. To make you very simple understanding, we will be having a manager. We will be having our manager and we will be having our team members. We will be having a team members. So what we will be doing, your manager will be having a complete understanding of all the employees or all the team members, correct? And we will be providing a status to our manager. It's via through calls or it's via stand-ups or via emails or whatever it is. So because of that, with that information, your manager always will be up to date about what's happening in the team, right? Yes or no, guys? Same concept applies here. Like a name node is a master, data nodes are the slaves, or data nodes are the, you can say, workers, the actual work horses. The name node is a manager. What the manager will do, he actually maintains the meta information. It means what's happening in the team, what's going, who stores what, which data is there, which location. That information will be there with the name node. The actual data, whatever the data you are trying to load into Hadoop, that data will be break into pieces and it will be loaded into this. That we'll see how it will be break into pieces and we'll see. So that will be loaded into these machines. It means your data nodes are actual worker horses who actually stores the data. Is that clear to everyone? Any doubts so far about data node, about name node?
No, Ravi.
Anyone? So whatever the data you load, the actual data is going to load into the data nodes. That's the reason we'll call them as the data nodes. The name node actually maintains the namespace information. Namespace information means the path. This is the file. It has been broken into these pieces. This is the block size. So actually it maintains the metadata information. That's the reason we'll call as a name node. So gateway is anyway is an entry point to or entry point to connect with the master or your cluster. Now, if your data nodes fail to send a signal 3 times, it means within 10 seconds. Let's say if I didn't get any signal from one of the data node within 10 seconds, I'll consider that machine is not alive. I'll consider that machine is not alive. If continuously, let's say there is a one employee, he's working on the remotely from the different location, he's not given any update from past 4 days or 3 days, he's not reachable via any communication channel. What we will understand, maybe that guy is on vacation or leave. So will we consider that guy for any assignments? The new task is there or new Jira ticket is there. Will we consider that guy for assignment? We will not consider, because we don't know what is his status. We don't know whether he is coming to office or not. So we cannot consider him for assigning a task. Similarly here, if any one of the data nodes fail to send a signal continuously 3 times, we will consider that machine is not alive, not in network. So we will not consider that machine for any further assignments or data storages. If it is recovered back and if it starts sending the signals, like this guy came back to office and started sending the status, started available via any of the channel, then we will consider him. We'll understand what happened to him and we'll consider from him to assignment other tasks. Similarly here also, if your data node didn't send a signal continuously 3 times, we will consider that machine is dead. We will not use that machine for any process or any storage. Is this clear to everyone? Is this clear to everyone?
Yes, Veera.
Okay. Next, try to understand the component by component. Then we will see the data load, how the data will load. Let's see the component by component. The first component is name node. The first component is name node. Try to understand more about the name node now. What is the name node? Name node is the master who actually I can say who actually stores the metadata information about your data nodes. Okay, let me write it here. He's a master who store the metadata information. Who stores the metadata information in 2 files. Image file, we'll call fs image, and edit log. Edit log. There are 2 files will be there for the name node. There are 2 files will be for the name node, which actually maintains the metadata information in those 2 files. And it is a single point of failure. It is a single point of failure. What is a single point of failure? If name node fails, if name node dead, we cannot process any data or we cannot store any data. Let's again compare with our team. If manager didn't come to office that day, most of the people will not work. The client cannot, I mean, we have other channels like a lead or someone will be there, they can update, but actually there won't be huge progress in that day. Correct? So since only manager is exposed to client, no one else, only manager is giving the updates to the client. If manager is on off, there won't be any updates to the client that day. Correct? So single point of failure. Here, if the name node fails, whole cluster is not accessible. Okay? Next, who actually monitors, who actually assign the tasks. So those are all actually comes under name node only, but we'll talk about that. There is a different daemon for it. Next, data node. It is a slave node. We can say instead of slave, who actually worker node, who actually stores the data, the actual data, who actually stores the actual data in the form of blocks, in the form of blocks. Okay, so who will communicate with the manager, I mean say master, who will communicate with the RPC protocol to the manager, who actually communicate with the manager with the help of RPC protocol. It's a slave node. And there will be a task tracker process. If you take a Hadoop 1, there will be one more process will be running on it. Not only storage, it will also process the data, right? These are the worker nodes, or I can say process nodes, right? Edge node is the gateway node where we will connect to the cluster. Now try to understand now, if you understand the components, try to understand how the data will load into the Hadoop. We'll call it as a write flow. Writing the data into cluster, we'll call it as a write flow. Write flow. We'll go with a simple example. I have a file. I have a file. I have a file. The file is 1 GB file. I am taking a small file to make the people understand very much clear. So I have my cluster like this. We will call it as a cluster. Cluster means collection of machines which are connected in a via network, and they're working as a single machine. We'll call it as a cluster. So if you want to load this data into Hadoop, we will execute some of the command. We'll write some code, right? Let's say I have written a command, the very much old command, I can say Hadoop FS. Hadoop FS means I'm trying to use the Hadoop FS. So why I need to use the Hadoop FS? Why can't I use the direct command? Because let's say this is your hard disk. I have explained this in earlier class, but again I'm repeating it here. This is my hard disk, and you will be having operating system. When you have an operating system running in your machine, it means you will be having one file system, correct? You will be having one file system. This file system will call as a local file system, and you will be having your OS here. For this operating system, it is a local file system because this operating system will be in this file system. So it will be whatever the file system you have in that system, that is a local to your operating system. So we'll call as a local file system. It is not remote, or it is not something else. So on top of this, when you install Hadoop, when you start your Hadoop services, you will be having one more file system. Can anyone tell me what is that?
HDFS.
We will be having one more file system on top of this. We will be having one more file system on top of that. That is Hadoop file system. That is Hadoop file system. So now, if you want to interact with your hard disk or reading the data, writing the data, if you want to do some operations, if you want to do with the local file system, we will use normal Linux commands. Normal Linux commands like ls, grep, vi, right? We will use normal commands, cp, mv, or whatever it is, remove, whatever the commands you will use in the local file system, which will actually which will work on this hard disk based on the type of operation you perform. If you are interacting to HDFS, actually you need to tell, hey, I'm using a different kind of file system. So if I directly use it, it knows, because we're using the local file system. So I don't need to explicitly say to these commands, you need to work on the local file system. I don't need to tell that, because it's a by default. That's a default which there is this. But when I want to explicitly connect through a different file system, I have to tell I'm using the Hadoop file system. So for that I have to use the Hadoop or HDFS DFS as a prefix to my commands. So it has its own set of commands. We will be seeing them. So I have to explicitly tell them, okay, I'm going to use these commands to interact with this file system. So that's the reason Hadoop FS, Hadoop file system, or HDFS DFS. We'll see the difference between these two also. Okay, Hadoop FS minus copy from local, or you can use the put also. Copy from local. What I'm trying to do, I'm trying to copy from the local. It means from this file system. So I have to give the local path. Local path is nothing but your edge node path. Your edge node. In the edge node, wherever you have a data, that path. And destination path, HDFS path. And HDFS path. So in HDFS, where you want to store, because HDFS also a file system, correct? Because HDFS also a file system. So where you want to load, we have to explicitly say that. As soon as I execute this command, what happens? This is the most important thing. So you will execute this command in edge node. Here you will execute. There will be something called DFS client. DFS client. There will be something called DFS client. What this DFS client will do, first to understand the path, the local this path, whether this local path exists or not, it will check. Whether the local path exists or not, it will check. Once it is exist, as per the configuration, so if it is a default file system, it has the default configurations. It has its own configuration. If it is a Hadoop file system, the Hadoop file system will have this own configuration, correct? It will have this own default configurations. What is the default configuration of this? Block is 128 MB in Hadoop 2. Replication factor is 3. And there is something called min replication copy is 1. Max replication copy is 512. These configurations will be there with the HDFS. Every file system will have their own configurations, right? Similarly, HDFS has its own configuration. As with respect to this configuration, the data will be chunked into pieces. As we know that whatever the data you want to load into the Hadoop, any file system, it has to chunk into pieces. Then only it will store into the disk. These chunks, it will be having some unique identification number. We'll call it as a block number. Every chunk will have a unique identification number. So for 1 GB, how many blocks will come? Very simple calculation. 1 GB means if you convert into MB, because our block is in MB, 1024 MB by 128. Very simple calculation. So you can open your calc. 1024 by 128 MB. It's a very simple calculation. You'll get the 8 blocks. You'll get 8 blocks. So 8 blocks will be created. Then your DFS client, because I'm going to store into HDFS path, correct? Now it will check whether this HDFS path exists or not. It will check whether this HDFS path exists or not. If it is exist, it will not store, guys. It says that the path is already exist. It will exist. If you give the file path, it will not store. If you give a folder path, inside the folder the data will store again. But if the same path exists, it will not store. When you say path, it's including a file, right? So, and also then it will go and talk to the name node saying that I have to store the file, right? So what your name node will do, he will also have some kind of checks whether that user is permitted to store or not, whether the user is permitted to store or not, whether the path is already exist or not. If the user is not permitted to store, as soon as you execute this command, it throws in a permission issues. It will throw in a permission issues, correct? So after doing all the checks, it says that okay, fine, you can store. Then what will happen? Your edge node will take the first piece. First piece. Try to remember this, guys. It will take the first piece, not the whole file. It will take the first piece, which is block 1. Now it will go to the name node saying that, hey, name node, I want to store this block 1 in the cluster. My replication factor is 3. My block size is 128 MB. This file is belong to some file name. Let's say file is Amazon file. This file is Amazon.log file. Then your name node, so look for the to whom we can assign. Same like our manager. If any new task comes, so you will find the person to store assign the task, right? Similarly, it is actually finding a how it will find because it also has some policies. It cannot go ahead and blindly find. It also has some policies. The policies will call block placement policy. Block placement policy. Please make a note. Block placement policy and rack awareness. These two are important actually. We'll talk about them. So with the help of that policy, it will identify some missions. So let's assume that it has identified the first mission, it has identified the third mission, it has identified the fifth mission. I just taken randomly. It can take sequentially also. Okay. So after identifying 1, 3, 5 missions, it take their IP addresses and tell to the edge node, you can store this data in these missions like 1, 3, 5. While it is giving that information to the edge node, what your name node will do, no? It will sort the missions. What is the sort? Based on the network distance from the client. If we see the racks, your client means your edge node. So there may be 2 missions in the one rack, correct? So we'll talk about the rack awareness. That time you'll understand easily. So whichever the nearest to the client, that will come first. Whichever the next nearest, it will come next. Next nearest, it will come like this. So It'll sort based on the network distance to the in between the client and the data nodes. In between the client and data nodes. So based on that, it'll sort and give. As soon as it gives, it stores that information in the cache. Who will store? Your edge node will store in the cache. 135. Then the piece of data, whatever the data we're trying to store, right? It will take that piece because it cannot send this much big block through a network at a time. So 128 MB is a very big. It's not very small, right? So this 128 MB also will divide into packets. I mean, before that, it will connect to the nearest machine. Then it will tell to the machine you need to connect to some other machine because it has that information. It tell to that machine also you have to connect other machine. Now 1 is a sender to 3, 3 is a sender to 5. So it will build this pipeline. It will create this pipeline. After creating a pipeline, it will chunk your data into packets. Actually, it can also cannot send the bigger piece right at a time. It will chunk into packets. These packets will be sent via network. So as soon as the first packet comes here successfully, the same it will store and the same packet will send here. The same packet will send here, and it will send the acknowledgement. Hey, I have received it. So that's a general network concept. If someone is, I mean, the receiver receives the packet, it will send the acknowledgement. Then it will also send acknowledgement to this guy because there are in a network. So this guy sends acknowledgement. Hey, we have stored. I mean, we have received this packet. Send me another packet. So similarly, it will try to store the complete block. It will try to store complete block. Let's say they have stored the block 1. Now that information, the data nodes will send to the name node saying that, hey, we have stored this piece successfully. So your name node, what it does? The file is Amazon. The block 1 came. The block 1 stored in machine 1, machine 3, machine 5. Machine 5. Similarly, it repeats the operation for all other blocks. It repeats the same operation for all other blocks. Block 2, this time block to some other machines. It can be 2, 4, 6. Block 3, it can be 1, 2, 3. Like that, it repeats that operation to all the blocks till 8 blocks completes. And try to remember one thing, guys. Until it successfully copies the all 8 blocks, the job will not be completed. If it stores only 2 blocks and fail to copy all other data, the job will not be completed. The data will not be loaded partially also. Okay. And while it is storing the data, until it completely stores successfully in HDFS, the data will not be available for read and write, for read and other processes. Okay. So this is how the data will store into the Hadoop file system. Any questions so far? This is a complete process. It's also most important for interview and also most important for our understanding how the data stores in HDFS. Now the whole data distributed across the multiple machines in the cluster. It is not in a single place or it's not in a single machine. The whole data is there in the different cluster, different nodes. Any doubts here?
Hi, Vera. This is Pradeep.
Yeah, Pradeep.
See, in Hadoop system, in the Hadoop ecosystem,
Hmm.
we will use only HDFS concept for file saving, or is there any other methods where we can instead
Only
of name node and
HDFS.
data?
Only
HDFS, right?
HDFS. Only HDFS.
Even though if we use any other partner networks like Cloudera or Hart, basic concept is the same.
You take any distribution like
Yeah.
Hortonworks, Cloudera, Mapper,
Uh,
whatever you take,
uh,
the data will store like this only in Hadoop.
okay. Okay.
Any other question? No, if no questions, we'll just move to the next topic. Don't hesitate to ask any even small question also. There is nothing like small or big. Ask any questions. Now once it is successfully have that metadata information, okay, the data is successfully stores. And so you may have a question, sir, I have copied one piece here, while copying to machine 3 and machine 5, it is failed. What will happen, sir? It's an interview question. So I'm storing a block 1, which is supposed to store in 3 machines, but it stored only 1 machine successfully, while storing other machine is failed. Can anyone tell me, will the job will continue for the next block or the job will fail? So block 1, I'm trying to store one packet received here while sending other packets to other machines, which is failed. It means instead of 3 copies, it stored only 1 copy successfully in one of the machine. So will job continue for take another block or it will fail?
If the process what you explained, like block by block, if edge node communicates the main node, then it should fail.
It will fail. That's what you're trying to say, Manish?
This is Venkat.
Venkat,
Yes.
okay. It will fail. Okay. Anyone else?
Actually,
Does it just throw
thinking,
an except?
Go ahead.
no, I'm thinking, will it search for a new, I mean, let's say if writing to 3 fails, will it search for a new node or?
It will not search for the new node because already it has taken that information from the name node. It will not go back again and it'll get the other mission. No, it will not get another mission.
Okay. Anyway, this is going to be the master node, right? The other ones are the slave nodes. So I think job will fail in that case. Even I'm thinking that.
Okay. What about Banu, Venkat, Tej?
See, I feel that it might just throw an exception that it could not copy to that node, and it might complete successfully because it did one part, it saved in one node, and the other 2 nodes it might just throw an exception, it could not do it, and then complete it.
It will success. You'll say it will success.
Yeah, success with an exception.
No exceptions. If exception means the job is failed. So no success with exception. Either fail or success. Okay. What about
I
others?
think it will fail.
It will fail. Okay. Good. So
No, it will success the job.
okay. Yeah. So simply it'll success the job. Okay. It'll not fail. Okay. Job will be success because while I'm saying that replication, I said the minimum replication something, right? And maximum replication. So the minimum replication is 1. It means we are telling to the cluster at least 1 copy you store successfully. If I change my minimum replication factor to 2, if I'm telling to my cluster you store minimum 2 copies of it. If I change this to 3, at any cost you have to store all 3 copies. If you are not able to store all 3 copies, you will try 3 attempts and fail the job. So that's where the minimum replication factor comes into picture. Minimum replication factor to come into picture. Okay.
But when you are explaining, you said it will take the block 1 and go to the name node, and name node will get us the 3 nodes that are supposed to be, that you have to copy the block 1, and you send that block 1 in packets to the data node 1, and it goes to the data node 3 and 5, and 5 return backs to 3, and 3 return backs to 1. Yeah, and then 1 return backs an acknowledgement to the edge node, right? So if 1 does not return the acknowledgement to the edge node, how come edge node knows that even 1 block was successfully loaded?
Here the data node 1 sending the acknowledgement, right? So it actually sends the acknowledgement of the 3 and 5. So if I didn't receive the acknowledgements of the 3 and 5, I will not send their acknowledgement, but I'll send my acknowledgement, right?
So it happens on the same time, like it sends acknowledgement to 3 and then sends acknowledgement to edge node also?
Yeah, all 3 acknowledgements it will be sending by the data node 1 because it's the only entry point to the client or edge node.
Oh, question is from the data node to the edge node and from the data node to the node 3. Will those 2 acknowledgements trigger on the same time? Like sequentially one after another, or is there any dependent between that triggering and this triggering?
There is no dependency actually. So if I didn't receive acknowledgement from 3 and 5, it means that something went wrong. So we will not consider that machine for the further sending the packets. So I'll get the only whatever the data I get. So see, your edge node has to get the acknowledgements, correct? So
Yes.
if your edge node get the acknowledgement from any one of the machines acknowledgement, it will send the data to another packet to the same machine. Whichever the machines I didn't receive the acknowledgement, I will not send another packet again, right?
That part I understood, but my part is like when one packet goes to the data node 1, right? And then that packet will be sent to the data node 3, and 3 is supposed to send the packet to the data node 5.
Correct.
And then 5 returns the acknowledgement to 3, and 3 returns acknowledgement to 1, and 1 returns acknowledgement to the edge node.
Correct.
So let us say data node 1, after sending the acknowledgement, it failed. Now data node 3 has to send acknowledgement to data node 1.
No. So now we need to understand one thing here. So if data node 1 send the acknowledgement and it failed, so your edge node again has to connect to the one more node, right? Or the pipeline, what you are trying to say, this acknowledgement is failed, correct? I mean this is broken.
So at any point of time, the edge node gets an acknowledgement from the first data node it is sending the data to. Is that correct?
Correct. So if I didn't receive the acknowledgement from the data node 1, okay, let's assume that data node 1 is failed, not 3 and 5. Okay, so what will happen here? Your edge node has to connect to any one of the node, correct? So since the data node 1 is not responding to the edge node, what edge node will do? The next availability machine is this. It will try to go, because it's already stored that information in the cache. So because the data node 1 is not reachable, it'll attempt 3 times. Okay, it'll try to ping that mission, and if it's not responding, then what will go? It'll go and ping the next mission like this. It'll directly ping to the third mission. It'll connect and store. I mean, try to send the data in it. So that is the reason. No, sometimes you will be seeing that under replicated data. Even if it stores one copy, it will success. But that's the reason if you go and see in your cluster, you can execute that HDFS FSCK Hadoop FSCK command. You will see that report under replicated pieces or under replicated machine. I'll tell you simple example, guys. Normally we will be using AWS. I think I know that few of you are aware of the AWS. We will spin up 10 machines. You have done your computation and you have loaded the data in HDFS. Then you reduce the machines to nodes. I'm talking about, not the task nodes. I'm talking about the core nodes. There is something called core nodes and task nodes. So you reduce your core nodes. Task nodes, no problem, because those machines are used only for tasks. So core nodes are meant for the process as well as storage. So you reduce your core nodes to 5. What will happen? Whatever the data is there in other 5 machines, it will be under replicated. So when you go and query Hadoop FS, when you say Hadoop FS, it will clearly gives you that under replicated blocks. These many are the under replicated blocks. But also one more thing we need to understand: in AWS, EMR replication factor is only 1. By default 1. In EMR, the replication factor is only 1. Yeah, so someone was about to ask a question. Please go ahead.
I have one small question. I mean, like, I didn't get, I think I missed out something. So how long will the node 1 wait before it gets acknowledgement from node 3?
Some few seconds.
I mean, like, once it sends in.
Few seconds.
Okay. Is it possible to set the time for it, or like
no, we don't have any
default?
It's a default.
Okay. Thanks.
Okay. So move on to this is how the data stores in this. So let's try to understand the Hadoop architecture from the Hadoop 1 and the recent versions, how it is actually worked. Okay, in the Hadoop 1, we have something called secondary name node. As we discussed, the name node is a single point of failure. So what that actually the communication was happening earlier. So earlier we used to have one is name node, and other one was secondary name node. So we'll try to understand now the roles and responsibilities of the name node. Let's say this is name node. So it has all the connections with the data nodes. Okay, this is secondary name node. Okay, I'm talking about Hadoop 1, Hadoop 1.x. It is Hadoop 1.x. Okay, so whenever you try to do transactions, whenever you try to do a transaction means writing the data, updating it, deleting it. When you try to do that kind of operations with your name node, I mean with your respective edge node, so those things will call as a transactions. Those will call as a transactions. For time being, you keep your name secondary name node aside for time being. Let's try to understand what happens in the name node. So the primary task of the name node is, as soon as the transactions are happening, anyway those transaction information will go in the RAM. Anyway those transaction information will be in the RAM because it is in live process. It is happening. So your RAM has that information anyway in the form of objects. In the form of objects, that information anyway it will be there. And also what it does, that information name node actually maintains two files. Name node actually maintains two files. One is edits, we'll call as the edit log. Some people call transaction file, some people call log file, or whatever it is. And there will be one more file called fs image. There will be one more file called fs image. This is the primary roles of your name node, guys. Try to understand here. So whenever these transactions are happening, what it does, this transaction information anyway it will load into the RAM, anyway it will be there into the RAM to make it persistent. Because if it is there in the RAM, it's a temporary. So as we know that RAM is a temporary memory, correct? It is only used for the process. It cannot be used for permanent storage. RAM cannot be used for the permanent storage, right? So in case of failure, we may lose the data. So to avoid that, what it does, it will keep those transaction information in the edit file. It will keep the transaction information in the edit file. How long your name node runs, the whole information will be kept in the edit file. Let's say my name node is running for a longer time, it will be putting into this machine. This file will be keep on growing. Okay. Now here, then whenever your name node restart, or whenever your name node is failed and recover it back due to network issue or something, whatever the reason. So what it does, because it should understand that what are the data it has been stored successfully, first it will take that edit file. It will read through, and it will get the information about the file system. Then it will merge with the FS image. Actually, we'll call it as a merge process, but we should not say it's a merge process. It is actually finding that your file system information, where and all the blocks are stored, what is a block, who is the author, who is the owner, so that information. Okay, so that transactions information will be put into the FS image. That FS image will be loaded into the memory. By the time your data nodes will be sending the heartbeat, they also will be sending the block report. So the condition is while it is doing this process, because the edit log may be bigger one, while doing this process, your name node will be in a safe mode. Can anyone tell me what is a safe mode? It is a read-only mode. Because you cannot write any data into the cluster at that mode. You can just read the data from this. Okay, you cannot actually perform any other operation apart from reading. It's a read-only mode because it's in this, it will go to the safe mode and try to collect all the information. So by the time your data nodes also will send the heartbeat or block report information. So once they send that block report and it is successfully loaded that information, and the data nodes are sent that at minimum copy. Suppose if I have supposed to send 3 copies, I send 1 copy, it's fine. So it means 80% of the data node sends their copy information, it is fine. Okay, then your machine is happy to start. So then once it is loads that information, your name node come out from the safe mode, then it will start functioning it. So what is the limitations you see here? What are the limitations you see here? If your name node runs for longer time and fail, what will happen? If it is a recoverable fail or if it's just a restart, it will take the, because this process has to happen, no, it will take longer time to come to the roles and responsibilities. It will take a longer time to restart, because it will be long time in safe mode. It will take a lot of time for restart and get into the actual functionals. And the other one is, if it is completely dead, unable to recover, there is a possibility the whole data we may lose, because that metadata information is there in this. The data is there in the data nodes, but we don't know where the data is because the metadata is not recoverable. There is a possibility of the data loss. So to avoid these two issues or limitations, the Hadoop team come up with something called secondary name node. That time only, when they introduced 1.x, that time only they come up with something called secondary name node. Okay, now you guys understand the name node responsibility. When you start the name node, what will happen? First, it look for is there any edit files which I need to merge. It will start merge the edit files with fsimh. This is the first task name node does. Is there any edits? Is there any transactions which I need to merge with fsimh? So what information will be there in the edits? What information will be there in the fsimh? So in the edits, guys, you will be having operation code, OP code will call operation code, transaction ID, user, group, permissions, whether what operation it is. So that information will be there in the edit file, whether it's a write, read, or what operation it is. Okay, when it comes to the fsimh, whether it's a file or folder, if it is a file, size of the file, number of blocks, each block ID and block size, all the blocks, how many blocks are there? Who is the user, he's belong to which group, and their permissions. That information will be there in the fsimh. So edit log will have this information, operation code, transaction ID, and user group, and all this information. Your fsimh will have the file system information. So with the help of this information only, your name node is will be actually take roles. I can say like it act as a master. Is this clear so far? What is the name node does?
Sir, ఇది ఎప్పుడైతే name node restart అవుతుందో అప్పుడే ఇదంతా.
The merging process will happen. See, it is not like when it restart. While doing the transaction itself, your edit log will have this information, and this information will get from the edit log. While doing this merge process. We'll actually call it as a merge, but it's not a merge process. It's actually It processes and takes the necessary information. While doing this merge process, it will get this information. But while doing your operations, while you are interacting with your cluster, this will happen. The transactions, what is the transaction, who did the transaction, when the transaction happened, all this information will be there in the edit log, type of transaction, all this information.
So when the merge process will be happening?
When your name node restart, that's what. When your name node start or when your name node restart, that time only it will happen. The merge process will be triggered when the name node start. First operation to perform this only, merge process only.
So how, in a real time scenario, how often the name node will be restarting? Like once in a day, once in a day?
That is the reason I said it is a Hadoop 1. And also I didn't complete it. You have something called secondary name node. It doesn't happen very frequently. So you have something, so to avoid some limitations, we come to the secondary name node. The secondary name node actually reduces those burdens. So that's where we need to understand completely. This is a very, I mean, whatever I have explained is the name node responsibility. Whether it will restart or whether it will do the merge process and all, there are some other guys has been introduced to do that merge process. Name node no need to do the merge process now. There are other guys to do it. That merge process will be done by the secondary name node now. Actually, that has been shifted. Understand, Venkat, what I'm trying to say?
Okay, got you. So there is some other work that secondary name node.
Yes.
So in the one.x we have name node and also secondary name node.
Yes. In one.x we have a name node and secondary name node. So this is actually the operations. What I'm trying to say. These are actually operations. Okay. These are actual operations which is has to do by name node. So because of this, so if we keep on doing this merge operation, you know, name node never come into the role and take the requests of the mail, either writing the data or processing the data. So to avoid that delay or to avoid the data loss, they brought something called secondary name node. They brought something called secondary name node. What they did with the secondary name node, this merge process has been given to the name, this guy, secondary name node. What they told to the secondary name node while configuring, hey, every 1 hour, anyway you will be having edits and all. This is very much common because this is the major important files for the name node. So while configuring your secondary name node, we'll tell to that configuration every 1 hour, talk to the name node, take the edits, do the merge process with FS image every 1 hour, or every 1 million transactions. Every 1 million transactions, every 1 million transaction, talk to the name node, take the edit. I mean transaction edit file. Edit file will be there in the name node. That's what I said. Files will be there in the name node machine. Take the edit files from the name node, do the merge process. So now this role has to given for the secondary name node. This secondary name node, what it does, every 1 hour it does. So let's look at how it will happen here. So let's say I have started my job at 8 o'clock. I mean, my name node is 8 o'clock. I started doing the operations. When I'm doing the operation, that information will go to the edit file. That information will go to the edit file. FS image will not be having anything to do with at the time of transactions. So at 9 o'clock, because it has been told to 1 hour, right? So let's assume that 1 million transaction didn't happen 1 hour. So your secondary name node will go to the name node. It will go to the name node asking, hey, give me edit node, edit file. Give me edit file. It will take the edit file. Then also it will take the FS image. Then it does the edit merge process. It does the merge process. This is updated FS image. At 9 o'clock, as soon as it is given to the secondary name node, the edit one, let's say it's the edit one file. This edit one is already given to the secondary name node. It creates another file because the new transaction has to store, no? It creates another file and start write the data in it. So whenever the next 1 hour is reached, it will also take this file. It will merge with FS image. and it will create a updated FS image. Similarly, this is 9 o'clock, this is 10 o'clock, so it will create one more file. Like that, the process will happen. Every 1 hour the secondary name node does the merging process. Now let's say at 11 o'clock it has given the file to the secondary name node. At 11 o'clock it has given to the file. From 11 there will be new file, correct? From 11 there will be new file. At 11:30 my machine restarted because of some reason. Either it's manual restart or it's due to some it can be power fluctuation, or it can be service down and up, anything. So it happened at the 11:30. Your name node restarted at the 11:30. Now you guys tell me how much data it has to merge. Your name node has to merge, not the secondary name node. Secondary name node will not do that, because secondary name node will do only whenever it reaches to 1 hour when it's running. Now the responsibility is for the name node, because name node restarted. So what name node has to do? It has to merge that edits with the FS image. So now tell me, name node has to merge how much data? From 8 o'clock or from 11 o'clock?
From 11:30. From 11:30.
Not from 11:30.
From 11.
From 11
From
to
11
11:30. Yeah.
11 to 11:30, right? So does it has the 11 to 11:30 information with it, which is not updated one, which is not updated. So where is FS image, which is there in the secondary name node? Then it will go and explicitly request to give the secondary name node for the updated FS image. It will take that FS image. It will take the edit from its own machine, then it will do the merge process. Now you tell me, I really no need to merge from the 8 o'clock. I need to merge only last half an hour, correct? So my restart time is reduced. Button is reduced, no, on name node. If you don't have a secondary name node, you have to merge all from 8 o'clock. Since you have a secondary name node, the restart is happening only last half an hour because of secondary name node. Yes or no? The burden is reduced. And also it can come out from the safe mode quickly. Only half an hour data I need to merge, not more than that. Half an hour transactions, I mean to say. And in case of failure, completely the data node is dead, unable to recover the files. How much data we may lose? Only half an hour information, because you have up-to-date FS image. You can bring the new name node, load this FS image into the name node, then you can get the up-to-date information. The only last half an hour I may miss. Last half an hour data I may lose. The data will be there, because I don't have a metadata, I cannot reference them. I mean, I cannot access them. You guys understand what I'm trying to say? Restart time is reduced, data loss also reduced. Is this clear to everyone or no?
So is the for 11 to 11:30 data, we have that edit logs in our name node one, right?
Correct.
So in that case, if it gets like a FS image from secondary name node, so why is the metadata loss there from 11 to 11:30? The edits are still there and it's going to merge with the secondary name node FS image.
No, I said in case of name node is completely dead, you are not able to recover the data. You are not able to recover the 30 minutes of data or transaction data because the hard is completely corrupted.
Okay.
That case, you have a chances of losing only the last half an hour transactions.
Okay.
Any other questions? Any other question?
Is there any route to create a new edit log in the name nodes? Like,
sorry, Venkat?
Based on the space. Okay. For example, you have a edit log in the name node, and I'm seeing a couple of edit logs. So the next edit log will be triggered or created based on the size of the previous edit log or the time.
Time, based on the time. Checkpoints, we'll call actually the checks, right? Whenever that the secondary name node request for it, whenever that successfully uploaded to the secondary name node, it will create a next edit file.
So once the request comes from secondary name node, automatically it will stop whatever the edit log it is having. It creates a new edit log.
Correct.
and send that edit log, whichever it is, previous one to the secondary name node.
Correct.
And that previous edit log will be there at the name node, or will be destroyed?
Yeah, it will be there. Your all previous 1 million edit files can be there because it's a configurable parameter. How many edit files you can have in the name node?
Okay.
That's a configurable one parameter. I'll show you that. So I can also show you that edit files in your machine also when we do the setup.
And I have one quick question. While doing the merge to secondary name node FS image, still the edit logs keep coming, right? What happens to those edit logs? Are they going to be stored in the name node 1? FS
Yeah, that's
edit.
what the edit log 2, edit log 3, and so on comes.
Okay.
It will keep store. It will be there in the remain will be there in the name node.
Okay, and after merging that, secondary name node will keep track of those again, or
Sorry, I didn't get you.
after, like let's say the merging process was done with the name node 1 from name node 1 to secondary name node FS image. So by the time whatever the edit logs came, so they will be keep tracked by the secondary name node because now
After
the
1 hour,
secondary name node has
after 1
okay.
hour or after 1 million transactions only.
Okay, so edit logs will be there in the first name node.
Yeah,
That's what.
the primary name node.
Okay. And how can we restore the? I mean, how can we get the FS image? Like, let's say if it was totally crashed, like the first name node and secondary name node, we can it is our backup for the first name node, right?
Correct.
So how can we restore that? Is there any command, or is it with the configuration that we can do that?
No, if name node fails, so we know that which location the files used to be. Okay. So we'll try to look the hard disk recovery people we can get that there is a tools, there are a lot of tools from we can recover from failed hard disk, right? So if it is we can able to recover it, so it's well and good. We can take the data, we can put into some other machine, and we can make it that machine as a secondary primary name node. Or what we can do, anyway this up to date information is there in the secondary name node, we can make the secondary name node as a primary name node, we can bring another machine as a secondary name node. See, if you have this edit file or FS image, right, what you can do, you can install your all Hadoop software in that machine, and you can create that location. You can keep this file into that location, then you can start the services. It will work.
Okay.
So, Ravi, if secondary name node gets restarted, let us say, then the name node, the primary name node will take care of merging the FS image, or will that be left over to the secondary name node until it gets up and then?
Secondary name node does not have a merge process while restart. In case of the secondary name node restart are dead, anyway that information will be the primary name node, and that's another limitation we can say. So that's also another limitation. That's where that new concepts came into picture. Like we will see. This was the earlier 1.x. So in the 1.
And how long? Okay, how long this 1.x was in the industry? Like any tenure, like from this year to this year?
It was there. It was, if I remember correctly, it was there till 2013-14. It was there till I think 13. It was there. People were using it. Later, I think even the Hadoop 2 came, but people have started using. You can see that, Venku.
Okay, I will see that history.
No, you can not history. You can see here. It's very simple. Like archive dot Apache. 1 second. Apache.org. Yeah. If you do this, if you go to the distant core, you can see here the Hadoop one till 2017 also it was there. But as I remember, it was there. This is the Then 2012, actually that's what I told you. So in 12 itself it just started making the Hadoop 2, but no, people didn't use properly. This was alpha version. So the actual
So
version,
2014 onwards, then
yeah,
2014.
so it was actually started using it. Okay.
And you said that the name node will go to the safe mode. It's only when the restart happens, right? So nothing on
There are
when
three
continuous.
cases. There are three cases, Venku. It's the most important interview question. So I will cover that again one more time. So one is when restart. Other one is admin can put into the safe mode for the maintenance purpose. Or third one is when you have a huge corrupted files in your cluster. So it will frequently go into safe mode. Okay, so that's it for now, guys. It's actually stretched 20 more minutes. So we'll connect in the next session. What I can say, we'll talk in more. So if you guys have any questions, please make note and please don't hesitate to ask. Please ask whatever the question it can be. Whatever this question it can be, I'll spend some time with you to answer all of them. Okay. So any questions, please make a note. We'll discuss in the next session. And most of you, I mean, few of your guys' emails are still not at which. Few of you guys' WhatsApp number is not there with me to update or to send the things. Please send all of them. Thank you, guys. Thanks for your time. Have a wonderful day.